Hello, I'm Papia. In this problem, we have the function f of x is equal to x minus 1 times x minus 2 times x minus 3. We have to first determine if Rolle's theorem can be applied to this function inside this interval from 1 to 3. If it does apply, then we have to find all those x values in the open interval 1 to 3 where the derivative is 0. If the Rolle's theorem does not apply, then we have to figure out why it does not apply. So let's recall the hypothesis for Rolle's theorem. So we have the function f. We have to first figure out if the function is continuous or not inside this interval. So that's the first hypothesis. Now look at the function. This is a product of three factors. There's no denominator, there's no radical. If you expand it, it'll just be a polynomial of degree 3, right? X times x times x. And so you know that any polynomial is continuous and differentiable everywhere on the real line. So yes, of course this function is continuous on the closed interval 1, 3 because it's continuous everywhere. And so in particular in this closed interval it will be continuous as well. Next, we have to check if the function is differentiable. Again, it's a polynomial and therefore it will be differentiable for all x. In particular, f is differentiable on the open interval 1, 3. And the last hypothesis is we have to find the value of the function at the endpoints. Okay, so let's do that. What is f of 1? So go back to the expression and then plug in 1 for x in the right hand side. So this will be equal to 1 minus 1 times 1 minus 2 times 1 minus 3. Notice that the first factor is 0 and therefore f of 1 is 0. Okay, let's figure out what is f of 3. So again, plug in 3 for x. So we'll get 3 minus 1 times 3 minus 2 times 3 minus 3. In this case, the last factor is 0 and therefore the product is going to be 0 as well. So this tells us that f of 1 is equal to f of 3. That is the third hypothesis for Rolle's theorem that is satisfied by this function. So notice all three hypotheses, they are satisfied. And hence, we can say yes, Rolle's theorem can be applied to this function. Now, since Rolle's theorem can be applied, we have to move on to the second part and figure out all those x values inside the open interval 1 to 3 where the derivative is 0. Obviously, we have to first find the derivative of the function. Set it equal to 0, solve for x. So, in order to find the derivative, if you leave the expression for the function the way it is right now, you have to do product rule. And then you have to combine all those terms together. So maybe that's not the best way to do it. Let's first expand the function, and then we will take the derivative. So let's take our function and use FOIL and expand it. So let me first keep the x minus 1 as it is, and I'm going to FOIL the last two factors, x minus 2 times x minus 3. Okay, so we get x times x, then x times negative 3, negative 3x, and negative 2 times x. So negative 3x and negative 2x, that will be negative 5x. And then negative 2 times negative 3, that's positive 6. Okay, now let's FOIL again using the first factor. So x multiplied to all three terms, we get x times x squared that's x cubed, then minus x times 5x, so 5x squared, then plus x times 6, 6x. Then we continue and we distribute the negative 1. So we get negative 1 times x squared, so negative x squared, negative 1 times negative 5x, that's positive 5x, negative 1 times 6, negative 6. Okay, let's combine the like terms. So we just have 1x cubed. Let's see, we have a negative 5x squared, negative x squared. So that's negative 6x squared. We have a 6x and a 5x. They're both positive. So you add them and you get 11x. And one constant, negative 6. So this is my function. And now we have to take the derivative of the function. Well, since this is a polynomial, every term you can just use power rule to find the derivative. So for x cubed, the derivative is 3x squared. Then minus 6 times derivative of x squared is 2x, plus 11 times derivative of x is 1, and then minus derivative of 6 is 0. So the f prime, the first derivative is 3x squared minus 6 times 2, 12x, plus 11. Okay, we have to find all those x or all those c so that f prime of c is equal to 0. So set this equal to 0 and solve for x. Okay, let's do it here. So we have 3x squared minus 12x plus 11 is equal to 0. Notice that this is a quadratic, right? We can try to factor, and if you do that, you see it's not, you can't find the factors directly. So let us just use the quadratic formula. So remember the quadratic formula. X is equal to, we have negative b, so negative of b is negative 12, so minus of minus 12, plus minus square root of b squared, so negative 12 squared, minus 4 times a, which is 3, times c, and that is 11, divided by 2 times a, and a is 3. So it's negative b plus or minus square root b squared minus 4ac over 2a. That's the quadratic formula. So simplify this, we get 12 plus minus square root, negative 12 square is just positive, and 12 square is 144, minus, okay, here we have to multiply these, 4 times 3 times 11, let's see, 3 times 11 is 33, multiplied by 4, 4 times 3, so we have 1, 4 times 3, 12, plus 1, 13. So this is 132, and divided by 6. All right, let's see, this is 12 plus minus square root. Okay, so inside the square root we have a positive quantity, which is good. So that means we will get some real values. So let's see what this is. 144 minus 132. It's 2, and it's just 1. So it's the square root of 12 over 6. Okay, so we can simplify this a little bit. Let's see. So we have 12 plus or minus. Notice that inside the square root is 12, right? And 12 is 4 times 3. So it's the square root of 4 times 3. Now 4 can be pulled outside the square root as 2, because square root of 4 is just 2. So you will have 2 square root of 3 divided by 6. And now note that both terms in the numerator has a common factor of 2 and denominator has a common factor of 2. So you can cancel out the 2 here and a 2 from here and a 2 from down here. So we have our x values where the derivative is 0, and they are, one of them is 6 plus square root of 3 over 3, and the other one is 6 minus square root of 3 over 3. Does this mean these are the c values that we wanted? Because that's where the derivative will be 0. You have to be very careful before you conclude that. Note, what we want is all those c's inside the interval, open interval from 1 to 3, where the derivative is 0. So you definitely have to check if those values are inside that interval or not. So to check that, just pick up any graphing utility and plug in those two values. So 6 plus square root of 3 divided by 3, that's almost equal to 2.58. And 6 minus square root of 3 over 3, that is approximately 1.42. Now let's check again. So 2.58, is that a number inside this interval, 1 to 3? Yes. 1.42 is also a number inside this interval. Therefore, we have found two different c values where the derivative of the function is equal to 0. Thank you.